Welcome to Arduino tutorial 4. Today we are going to be learning about servo motors, and we're also going to be learning about the serial port. If I go to the question mark and click on the question mark, it shows like how you can set it up. And actually, if I get out of this, you can go over here and they already have like a whole circuit set up. So I'm going to bring this over like this. I'm going to delete this component. And we have this all like linked up. Now you can see here that for the servo motor, there's 3 wires. You connect this left one to ground, the middle one to the 5-volt, and then this green wire, which goes to the rightmost port, rightmost pin, that is connected to one of these digital pins. Now these digital pins, some of them don't have a squiggly next to it and some of them do have a squiggly next to it. If it has a squiggly next to it, it has the ability to do pulse width modulation. So what is pulse width modulation? So you can see here that this is how you do pulse width modulation. Let's say you had an LED and you wanted it to be like 50% bright. What you could do is you could turn that LED on and off fast enough so that your eye doesn't detect the on and off. But what happens is if you do it fast enough, your eye thinks that instead of it being on and off, that it's actually at like 50% value. You could do that at 75, at 25%. You can see here at 75%, you have the pulse on for 75% of the time and then off for 25%. So then your eye would think that it was like at 75% brightness. And here you can see that it's on 25% and then off 75% of the time. So this is how you use, you can use pulse width modulation to make a digital component seem like it is analog. So if you go back to TinkerCAD, these pins, you can use these just to set things high or low, but the ones with the squiggly, you can set it for high or low for any digital component, but you can also use pulse width modulation. So we're gonna start. Arduino, there's a lot of people who've written libraries. It's like code that you can access for different things. So like servo motors are pretty common. And so there's a servo motor library or code that you can embed in there. And you do that by typing the following: #include servo.h. And what that does is it tells the code to go and find this library. Now, if you were doing this on a computer, you would have to make sure that you had this uploaded to your computer for your computer to access. So it could download that onto the Arduino brains, but it is already included in TinkerCAD. Now we're going to initiate a couple of integers. We're going to do some variables. We can have a variable for our servo pin equal to 9. And so that's basically saying that we're going to create a variable called servo pin. We know that our servo pin is number 9, so that's why we set that equal to 9, which is an integer value. So that's why you have int. And then we're also going to create a variable for the servo position. Servos rotate between 0 and 180 degrees. And so you can tell it to go to a certain degree value. So we're going to call that servo position. And make sure you're being very careful with your capitals and lower cases. On this one, I only have P capitalized. And we're going to initiate it in the header to start at 0. And then last but not least is servo. You're telling it that, hey, there's a servo, and that servo, that's like a general function for any servo, like based off of this library. But now we're going to tell it what our servo name is. So the servo name that we're going to call it is my servo. So that is our header. Next, we're going to do our setup stuff, void setup. And so what we're going to do in the setup is you have to have, when you do void setup, you have to have these 2 regular parentheses and then the curly brackets to initiate, and then you have to have an end curly bracket at the end to terminate that function. Okay, so here we're going to initiate 2 things in this setup. one is our servo, but the other is our serial port. So what is the serial port? Well, what we're doing is we're communicating between the brains of the Arduino and your computer. And so we need to tell it how to communicate. It needs to be communicating at the same rate. You can't have the Arduino, communicating at a different speed than the computer. That would get confused. So we start this by saying serial begin, and then inside these parentheses, we're going to put the baud rate. That's how the speed of the communication. And you need to make sure that your computer is set to the same thing. We don't need to worry about that on TinkerCAD. Okay, and now we're going to initiate the servo. So what we're doing here is we're telling the servo, my servo, which is this, to attach to pin 9. It's attaching to pin 9. But we created a variable, servo pin, so we can write in servo pin. Now, sometimes it's a good idea to just try running your code as you go, because if you have any problems, it will say, sorry, it seems your code has some errors. Well, see, it doesn't like it because there should be a loop, right? So we're going to keep going. Okay, so that's our servo. Now we're going to create a loop, because every program needs to have a setup and a loop. Void loop, again, parentheses. We can start with the curly brackets and then end with the curly brackets. Now let's see if we have the same error when we run it. Now it doesn't have that problem. So now what we're going to do is we want to communicate and be able to see what's going on. So we're going to do a print to the computer. We're going to have the computer monitor say something. So this by itself would be enough to print something, but I'm also going to write ln. ln means a new line. So every time it asks this question, it's going to ask it on a new line instead of just having a long string of characters. So print ln. If I wanted to do just text, if I wanted to say something specific, like at what angle to set the servo at. Okay, here we're going to say serial available equals 0, and then curly brackets. Basically what this is saying is wait until you get a character that makes sense, because we're looking for a number, right? So it's saying, look and look and look at the computer for something, but just wait until you get something that's a real character. So here we're going to end that waiting, and then here we're going to say, okay, servo position, we're setting this variable equal to serial parse int. What does that mean? This parse, oopsie, I spelled it wrong. Parse int. This parse means you're going to be parsing the information that comes in from the computer, and you're looking for an integer, int integer. So once it finds an integer, parses an integer character, then it's going to feed that into our variable servo position. Now, once you've done that, what are you going to do with that? So we now have servo position is whatever we input. It could be 45, it could be 90. It really needs to be a number between 0 and 180. But now we need to tell the server, my servo, right. It means now we're going to write that number to servo position, to the pin servo position. We're going to write that number there. And then last but not least, we can delay just a tiny bit. So let's try and see if we have any errors. Okay, great. So no errors. So now if we go and we click on here, down here at serial monitor, you can see it says what angle to set the servo at, and it's waiting. It's just waiting, waiting, waiting. So now I'm going to put in a value. I could say 45, and it turns it to 45. I say 90, it turns it to 90. If I say 0, it turns it to 0. If I say 180, it turns it to 180. Now what happens if I put in like 270? That the servo motor only has a range from 0 to 180. It doesn't know what to do with that, so it just left it at 180. But that introduces you to both the serial monitor and the servo motor. And this serial monitor is really useful because as you're trying to create a project, you might want to know what the value that's being read off of what's coming up. If you connect a value, a component to the Arduino, you might want to be reading what is that component outputting or inputting, and you can you can have it write to the serial monitor that value, and you could be checking your work as you go.